What we saw in the last few videos was a cool and interesting way of solving this factorial problem on a decently large input. And after we came up with this formula right here, we implemented that formula with some code where we said we would define this f function, and to solve f on n, we would first solve f on n minus 1 first. And then to find f of n, our original problem, we would multiply that answer to that smaller problem by n. Right? So solving 500 factorial is the same as solving 499 factorial right here, and then multiplying it by 500. And that led to us drawing out these method calls on different ends. And we noticed that this circular definition, where we have the definition of f utilizing f itself, if we just had these two lines, it would never end. And so that led to us implementing this base case where we said if n equals 1, well, factorial of 1 is really easy. We know that answer, and the answer to factorial of 1 is just 1 factorial, which is just 1. And I think one thing I forgot to mention last time is that this really, you can imagine this line right here, this line being an else statement of this if. Because if this line runs, if we return 1, then this line will never get run. Right? But if this line doesn't run, if we don't return 1, then only this line will run. So you can think of this as an else statement. In other words, either this will run or this will run, never both. So what I want to cover in this video is this concept of recursion, which we really just did right here. But I just want to put a more formal definition onto it, where if we have this concept of defining a function in terms of the function itself, right? That is something called recursion. And this is something you're going to see again and again in your undergraduate CS career, maybe your graduate, and maybe even your professional careers. This concept of recursion, where if I were to define it in one line, it's in, at least in terms of computer science, it is a method that calls itself. Right, and that's the quick and dirty way I would say to think about it. So there's a few general steps to recursion. The first one is to make your input smaller. Right, and we did that here, right? We had this input of n. What we did is we made that input small. We subtracted 1 from it. We changed factorial of 500 to 400. We changed 500 to 499. We made the input smaller. Right, so that's our first step right here. So the second step of recursion is that we solve the problem. What I should actually say here is we solve the same problem on the smaller input. In other words, we're still solving the factorial problem here. Right? We still want to know the factorial of the smaller input. So that is our second step right here. We made our input smaller, we changed n to n minus 1, and then we want f. We want to find f of n minus 1. And then our third step is to solve, or I should say, is to use 2. In other words, use the answer, use the solution to this same problem on the smaller input, use that solution to somehow arrive at the solution to the original problem. And for factorial here, that corresponded with taking the answer to factorial of n minus 1 and multiplying it by n. And that is the general form of recursion. If I were to label these 3 steps over here, we would say that making our input smaller would be changing 500 to 499. That would be our first step. Solving the same problem on that smaller input would be that step right there, finding 499 factorial. And then solving that original problem by using our answer to step 2 would be right here, multiplying 499 factorial by 500. And so that, in essence, is the bare bones breakdown of recursion.